So basically what I need to do, right, I'll go through the how to use MF27 in your A level. Then after that, I'll tell you what you need to know in the H2 math syllabus. What are the formulas not given MF27, what you need to take note of. Okay. But I think some things like your shoelace method, then sometimes like for example your R formula, all these, right, you feel like you do not know how to do it, right? So and then like for example arc length and all these formulas you need to know lah. So we need to run through it once. Then I'll also go through like some of the expression where some actually you can derive the formula one. Okay. Then what are principal values? Then like some of the integration formula also can derive, but some not so important. Okay, we start with the first one, binomial expansion here. Now binomial expansion, right, is what you learn in secondary school. So for example, right, if you were to do this kind of expansion in secondary school, you inevitably use binomial expansion. So basically in secondary school, right, you only learn things like that. For example, 2 plus 2x, okay, maybe 2 plus 3x to the power of 6. Okay, so if you want to do power of 6, any kind of positive integer, right, you use binomial expansion from secondary school. So this guy here. Then the next question is, how come we have a separate, like what's the difference between here, this guy, these two guys? Actually, they are not really a difference. You can use power series to use binomially, but just understand in secondary school, when we are doing this guy, this is nothing more than just Pascal triangle. So if you want to do binomial expansion, okay, let's say we put power 4. Okay, we know that if you were to expand this power 4, we have, like for example, if say we have 2 plus 3x, right, square, this would have 3 terms here. 2 times 2, 3x plus 3x square. Okay, so basically 2, right, you have 1, 2, 3 terms. Okay, the reason being is because this comes from Pascal triangle. Pascal triangle, whenever you do anything to do with choose, right, combination, you always start counting from 0. So like for 1, 1, 2, 1, 1, 3, 3, 1, and 1, 4, 6, 4, 1, right? So essentially, you start with n equals choose 0, n choose 1, then n choose 2, then n choose 3. So this guy, then this is n choose 4, not an issue. Okay, so basically for this guy here, remember, I mentioned this in in classes before, that if this is power of 4, you should know that you will have 5 terms spawning out. Okay, so this will be like here, 2, 3x. So you just need to draw like 1. So this is what you do in secondary school. Okay, basically there is an end to the expansion when this is a positive integer. Okay, so the one where we do in secondary school, right, they're all positive integers. So once you do that, what you need to do is then put 2 and 3x inside. So like for example, this guy here, you put 2 and 3x, 2, 3x, 2, 3x, 2, 3x, 2, 3x. Okay, then this is 4, 4, 4, 4, 4. Okay, so that's how we expand. Then the next thing is this. Understand that there's always a pattern when it comes to Pascal triangle. So you start counting from 0 first. So 0 will be, because this is 4, as 0, 1, 2, 3, 4. Okay, then the next thing would then be 1 would be ascending, 1 will be descending. So I'm going to choose the power of x will be ascending. So it's 0, start counting from 0, 1, 2, 3, 4. Okay, then subsequently the other one will be 4, 3, 2, 1, and 0. Okay, so that's how you use binomial expansion here. Okay, so I repeat, the reason why we have power series in Maclaurin series is because we want to deal with in our H2 math syllabus now, if we have this guy here, like say -4, then we need to use power series, because this will then not be a finite expansion anymore. Okay, they will be infinitely like many. So then, or let's say we have like 2 plus 3x, 3x to the power of half, which is very useful because we can find square root of 2, 3x. Okay, all these we need to use power series. Okay, just understand that. So this is n positive integer now. But what you need to know, the important part is that this guy is in the first page. So this one we use it in stats also for binomial expansion, binomial distribution. Okay, so this guy is NCR, the formula, and also this guy here, NC1. Remember in secondary school you learned this one. N choose 1 is n, right? So in secondary school you learn this formula here. NC1, n choose 1 is n. Okay, then n choose 2 is n minus 1 over 2 factorial. Sometimes in school, secondary school, you just learn divided by 2, but it's not exactly correct because n choose 3 will be n, okay, n minus 1, n minus 2, 3 factorial. Now, but what you need to understand is this. Actually, this formula is ingrained in the MF27. You look at this guy here. This guy, you will have, this is NC1. So NC1 is over here. This is NC1. Okay. N choose 2 is this formula here. Okay, remember that. NC3 is this guy lah. So that's why NC3 you can just sub when r equals to 3. You sub into this guy, you get this guy lah. Okay. So remember that. Now, then the question is then how come the formula this works? So sometimes you have to know why this is equal to this one. Okay, so this one here, okay, I'm going to give you an example. So say you have n choose 3, right? Okay, this guy, if we were to use the formula, which is this guy here, okay, if they ask you to show nc3 is this guy, so what you need to understand is this is like, for example, this is n factorial, this is 3 factorial, n minus 3 factorial, right? Okay, then remember, essentially, right, if we want to factorial is very fun to play because if I've got let's say 150 factorial, right? So we've done this many times. So 150, 149, then 148, then 147, right? Let's say you want to stop. Okay, you want to stop at 146. What you need to do is just basically, in order to balance the formula, you just put the x factorial sign behind. This will definitely be balanced, right? So the same thing goes with this guy here. What we need, right, is actually to expand this guy. So it is n minus 1, n minus 2, then n minus 3 factorial. You stop at n minus 3 factorial because you have a n minus 3 factorial below here. You will cancel the one on top. So this guy will be n minus 1, n minus 2, n minus 3 factorial over 3 factorial, n minus 3 factorial. Okay, so when you cancel this out, you will get the formula lah, n minus 1, n minus 2, 3 factorial. Okay, so this is how you essentially derive your secondary school formula. Maclaurin series expansion. Now, Maclaurin series expansion, just remember, you cannot substitute a constant value into the. So you can replace. Obviously, you can replace x with let's say x squared 2x. Not an issue. Okay, this is fine. Then you can replace x with, like, for example, x squared plus 3x. This is also okay. Okay? But what you cannot replace is that you cannot replace x with a constant, like for example 3 minus x. Okay, this one, as long as there's a constant here standing alone, you cannot do that. All right, so like x with let's say x 3x squared minus 1, this will not work as well. Okay, so just remember when we are doing like substitution, you can't do that because the rationale is very simple. It's not wrong but wrong. So the rationale is, say for example, if sine, you replace x with 1 plus x, right? Basically you translate lah. Okay, but the problem with Maclaurin series is because we need to definitively know in the question, we need to definitely know what is our a, what is our b, what is our cx square. We need to know all the coefficients there. Okay, the moment you do, like for example 1 plus x, right? Okay, I've seen some notes say that because 1 plus x is not small. Actually, this is not really true lah, because translation is not whether it's small or not. It's more of like, because you translate it and it becomes a Taylor series. Okay, so this guy will be 1 plus x cubed 3 factorial plus 1 plus x to the power 5 factorial. Okay, so essentially you cannot definitively know the constant now because every expansion behind here would have a constant. Okay, so if I ask you what is, like for example, what is a sine 1 plus x, the expansion, right? You cannot tell me what is this a. In fact, you cannot tell me what's a b, what's a c, what's a d, because all these, right, you need to expand to indefinitely in order to know all these coefficients here. So if you have sine 1 plus x for trigo ratio, remember what we do? We use addition formula. We want to separate the constant out. So we use sine a plus b lah. A plus b. So this is sine a cosine b plus cosine a sine b. Then you essentially, this is sine 1 plus x, right? This would be sine 1 cosine x plus cosine 1 sine x. then what we do is we use the standards formula. That's why I mentioned for A level, the small angle approximation question haven't come out for very, very long already. So you need to pay attention to small angle approximation questions. Okay, go back and practice those. It helps. So for the long one, remember to just make it 1. Okay, make it 1, and then for the power series, same thing, make it 1. Then you can start expanding. So I think for partial fraction, so some students forgotten that partial fraction is in the what do you call it? Is in the MF27. So you don't need to memorize per se, but just understand one thing is that whatever, let's say this is linear, okay? When you can do partial fraction, firstly, the degree on top, this must be a proper fraction. Okay, it has to be a proper fraction. You cannot be like haphazard. You cannot be like the top degree have to be smaller than the degree on top should be smaller than the one below. Cannot be. So meaning to say 2x plus 1, let's say we have x squared, x plus 1, 3x minus 1, in this one. This is not a proper fraction. Okay. Proper fraction means the degree on top have to be less than the degree below. So as long as it's not, you just do long division. Okay. So then the other thing is this, if you split into proper fraction, remember that if the bottom is linear, the one on top would be a degree lower. So if you see the bottom is quadratic, right? Quadratic. Then the top is linear. The top is linear. Okay, definitely. Then if you see the bottom is linear, the top is a constant. It will always be a degree lower. Then the next question is, Mr. Gang, how come this one is a quadratic, then this one is constant? Okay, this one, what happens is you can let it be c plus dx, but because it's a repeated root, right? The repeated root happens, right? The d will solve to be 0. Actually, the d will solve to be 0. That's why you don't see the dx there. Actually, you can put it as dx plus c, but because of the repeated root nature, right, the d will be equals to 0. You can just solve it, but I think you don't have time to solve it, but just understand that for partial fraction, the top is always 1 degree lower. Okay, repeated root, except for this guy, because of the repeated rule, you can put dx plus c, but the d will be solved to be 0. That's that. So Gareth is asking if, say you have let's say you have this 2 plus 3x to the power of 5, right? Am I right? Whether should I use the power series expansion, or should I use the binomial expansion, right? Okay, the power series expansion, I will use the binomial. You know why? Because this one has to be 1. If I want to use power series, I need to make this 1. Okay, so you don't use this one You don't use this one, but if say I've got 1 plus 3x about 5, then this is 1 plus x. So I can either use one of it because both will give me the same thing. Yeah. So it all hinges on the top in front, which is 2. If like say a plus bx, right? A is 1, then you can use either one. The power series, this one has to be 1. So that's the difference, yeah. Okay, then the next question for power series, there's another question which is whether ascending power and descending power would have to take note. So okay, in secondary school it's not an issue. If you want ascending power, descending power, if you want to ascend the power of x, right, you just need to ascend the power. Alright, so you just make sure you count 0 to 4 or in ascending order, or 0 to whatever number. If it's binomial expansion, right, because it's finite, you just make sure the x is in increasing power, then the other constant is in decreasing power. Okay, but then what then do you, okay, say if it's power series, how then do you make sure it's ascending power and decreasing power? So I'll show you. So say we have something like that, 1 plus 3x. Okay, so if you say I want this to be ascending power, what do I do? So ascending power will then be, this is just half, then I just directly apply the power series here, because power series by default, right, they will this one here will be descend, whatever is not the one, the other one will be the ascending power. Okay, this is 1. So essentially this guy here will be 1 plus half 3x plus half minus 1, 2 square, 2 factorial, then 3x squared. This is ascending power. So if you want this to be descending, what you need to do you just remember, it's very binary one. You have one ascending and one descending, right? So instead of making the 3x, instead of making this the 1, you make the 3x the 1. So for example, you just factorize the 3x out. So this case here, if I have 1 plus 3x, about half, I just factorize the 3x out. So this guy will be 3x. Then I'll put this as 1 over 3x plus 1 half. Okay. How come if I factorize the 3x out, I'll make sure it's descending. So if you look at this guy here, now I will just have to this half inside here and half inside here. So basically, what happens is this will be square root of 3x. Okay. Or rather 3x about half. So then this guy, I can just flip it to this guy, right? Okay, like that. Okay. So now, then to answer a question, how come if I were to factorize 3x, it will be descending? Because if you look at this guy here, you will increase this power. By increasing this power, you're descending its power. So this is 3, square root 3. Maybe I put this as square root x. Then this guy will be 1 plus. If you use power series, you get this guy here. Plus half. Okay. Then this guy will be half minus 1. 2 factorial. 1 over 3x, then you square it, then and so on. Although by virtue of squaring the power at the denominator, right, it becomes more negative in terms of its power. Okay, so if you look at this guy root 3, right, this is root x, right, this will be 1 plus 1 over 6 x to the power minus 1. Okay, the other guy would be negative. Is it negative 1? 872, I think, x to the power minus 2. Okay. So 9 times 9, 72. So basically, right, you realize that this one becomes more and more negative. So this is descending power. So remember this: if you want to ascend the power, you leave the x as a numerator, like in pos. Then if you want descending power, you just make sure that the x is in the negative region. Okay, so that's how you do it, Okay, remember this, So remember this, we mentioned this in Maclaurin series before. So if the just yesterday's lesson, actually, the Saturday's lesson, that tangent for when x is small in your syllabus, understand this, tangent x, okay, tangent x if equals to x. This one you need to write it somewhere. I mentioned this before. So if you want to find the Maclaurin series for tangent x, just remember tangent x equals to x is stated in the H2F syllabus. Okay. Then if you want to actually derive the formula for tangent x, this is how you do. So if say you forgotten, you can just do this one, sine x over cosine x, right? Then you use the standard series for cosine x and sine x to find the expression. So from this guy here, I'm gonna just take this one. Usually it's just these two, so I'm just gonna take this one. Remember, in your small angle approximation, if x is small, you can ignore the x cube. They will have to let you know what to be ignored, okay? So then the question is, how come when x is small, you can ignore the higher order? This one also another important thing. It's because if say x is very small, right? Okay, so x, let's say, equals to 0.01. This is considered small, right? So if it's x squared, then if x is 0.01, this will mean that x squared is equals to 0.001. Is it 0.001? I think. Yeah, x cubed will be 0.0001. Okay. Hey, am I wrong or not? 1, 0, 1, 0, 1, 2, 1, 2, 3, 4. I think is that will be 1, 2, 3, 4. Okay, so essentially when x is small, right, the highest degree will be close to 0. That's why you can ignore it. Okay, so but so for small angle approximation, they have to show you what can be ignored. So if you look carefully, the question, right, they will let you know, they'll say by showing to what degree. So tangent x, remember in MF27, it's stated very clearly that tangent x is roughly equals to x. Okay, and also I mentioned this in the previous lesson before. You can also think about this as this as x is small. Okay, there's one famous expression is tangent x roughly equals to sine x. Okay, the rationale is very simple. You can just think of it as like that. This is like a, say, a very small angle here. If x is small, it's very narrow, right? Small, right? So it's very small. Okay, one thing you need to understand is these two are roughly equal to each other. So basically, the opposite, right? This is opposite. This is the adjacent. This is a hypo, right? Understand that when x is small, okay, hypotenuse will roughly equals to adjacent side. Okay, so what happens is you realize like sine x, right, will be opposite over hypotenuse. Then tangent x will be opposite over adjacent. Okay, but because these two are equal to each other roughly, so that's why you can just write sine x is roughly equals to tangent x. Okay, so that's why when x is small, tangent x, you can just take tangent x as this guy, then you ignore this side. Okay, so there's one way to remember it. But in any way, if you think about this guy here, you can also derive in exam. But because in exam, if you've forgotten anything, you need to have a fallback system. If you don't have a fallback system, you will pee in your pen, obviously. Pee in your pens, right? So sine x, I'm gonna just take the standard series out for sine x, which is this guy here. Okay, you can just do this one. X, so let me take it out. Okay, so this is what we get. Then what I'll do is I'll just bring, so you need to apply this guy lah. So this is roughly x, this is 1 minus x squared over 6, right? For the top part is this guy. Then the bottom, you just take 1 minus half x squared minus 1. Then you just expand power series and so on. Then 1 plus half x squared. Okay, so then this guy x cubed, we need x cubed. Okay, we can put x cubed if you want to. Okay, so I'm gonna stop here because this one will be square cube power 4 lah, so I can just ignore. So this guy will just be x 1 minus x squared over 6 is 1 plus half x squared. Let's say if you want to find the tangent x, the question is show that tangent x is roughly equals to x plus 1/3, I think, x cubed when x is small. Okay, they can ask it like that. So you just do this long. It's very well this is in the syllabus, so 106 this is cube, so the cube can ignore. Okay, sorry, this is square. Okay, so I remember wrongly, this is 1/3. Yeah, okay, so that's it. That's how you show lah. Okay, remember that tangent x is roughly equals to x lah. Okay, that's how you show. So if question ever asks, which happens in prelims before, they ask you to show tangent x is this guy, so you just show. Okay, that's about it. So Maclaurin series is covered. Now we talk about
but then right,
this sine x expression is only for until here. You don't take the one, yeah. So it's only until the first degree. You cannot take more than. So the other way to think of it is this one is only to the first degree, yeah. But this is the pure Maclaurin series for tangent x. So you should expand it.
What is like beyond power of 3?
Then you have to derive. If it's beyond power of 3, right, the question have to ask you to write it down, yeah. Because in the syllabus outline, they only say you need to know tangent x is x. Okay, that's all. But if they ask you to show to the power of 3, you likely the first part they'll say show that tangent x is this Maclaurin series. Then you just do this step here. Then you get the Maclaurin series. Then you expand, yeah. So the one on the right. Yeah, the one on the right is only until x. Not more than, yeah. So for trigo formula is important. So the one which students may not know, or rather if you don't practice enough, you will not know, is that there are some formulas which you need to know in H2 math, like, but it's not given in MF27. So like this formula, sine A square plus cosine square A equals to 1. Okay, this one you need to. This is just a Pythagoras theorem. How do you prove this sine square a plus cos square a equals to 1? There are many ways to prove it lah, but the easiest way to prove it is that you use my favorite right angle triangle, which is my logo. Thank you very much. So what you do, right, is that you take this guy. Say this is a. Let's say this is x lah. Okay, opposite, adjacent, and hypo. Okay, so I know that by Pythagoras theorem. Okay, by Pythagoras theorem, we know h square is equals to m square plus n square. Okay, so then you also know that sine x, right, is equals to m over h. Then cosine x, right, is equals to n over h, right? So what you need, you just divide both sides by h square. Okay, then this is 1 m over h square plus n over h square. Okay, you realize this is you get your sine and your cosine. Just substitute it in. Okay, this is just a Pythagoras theorem if you want to like really think about it. So it's just like that. Okay, so there's that. Now then there's another one which we always use on, the secant square equals to tangent square something one, right? So that one, remember that you need to know how to derive divided by what? Cosine square x first. Okay, because when you divide by cosine square x, this guy would be 1 divided by cosine square is secant square. Then this tangent sine over cosine is tangent x. Then this will be 1. This is 1. Secondly, if you can divide by cosine square, you obviously can divide by sine square as well. Divided by sine square, this will be cosecant square x. Then this will be 1 plus cot square x. Okay? So this formula here you have to remember, because whenever you are told to find this integration like that, you confirm is it this one? This integration, sorry, this one can tangent square for x. Okay, you need to know that basically you cannot integrate tangent square. You can integrate secant square, you can integrate cosecant square. Okay, integrating secant square is tangent x, because differentiating tangent x is secant square. So essentially this guy here would be 1, this will be secant square 4x minus 1 dx. Okay, so you need to use this here to here. You need to use the formula of secant square a equals to tangent square a plus 1. You just, like most of the time in the question bank, whenever I use this formula, you always hear me repeating myself, please know how to derive this formula. Okay, because if you don't remember now, bro, you obviously will remember in exam time, right? Because you legend. I'll tell you what you only remember, okay? You only remember that Mr. Gunn said know how to derive. That's all you remember, okay? So know how to derive these two formulas, very important, okay? You use it in integration. You use it in sometimes improving also. All these are in MF27 also double angle addition formula. Then remember this one, you can replace a with x over 2, so you can also write this. Sometimes you remember all this you learned in secondary school before. You can change it to this guy here, change to half angle. Okay, so that one I just leave it to you. Now, the other thing that you need to remember is R formula. So now in R formula, mid-year revision set function, I've already gone through with you all, but I think I will just throw the worksheet here so that the newer students can refer to it. Okay, so there's one part in our revision set we gone through what do you call it? Okay, so you go down to your A level, right? So you go to revision set. I think it's prelim revision. There's a prelim revision 1, so it's under functions, which you have this called R formula. Okay, it's not this one. Yeah. Okay, later I'll put the function R formula things inside here lah. So you go back and listen to me. Yeah, just make sure the R formula you know how to do. Then you try these questions here, R formula question, because they are in the specimen paper. So but haven't come out yet. So but if you want to know how to get the notes for functions, you have to know that you have the secondary school notes here lah, but you don't have time to go through everything lah. Like obviously, you just need this one. This guy, there's R formula here. Okay, you have to know how to use the R formula. I think this is a addition formula, R formula. Yeah, here. So you can go and review this one. I will give you the access to the J2. I'll put it in the. So I'm not going to explain how you prove it, because there's a video online already. What you do is just understand that there are two ways to derive the formula. One is by comparing the coefficient of the cosine and sine. The other one is by using a formula. But I don't really like to use formula because, you know, if you don't remember the formula now, obviously you will not remember the formula in the exam. So I usually like to just derive it because it's also not very difficult per se. Okay, so this is R formula. Just remember, I will put the R formula worksheet. Wait, let me just put the worksheet in the group chat now. So what you need to understand is R formula question. Okay, let's say I'll just go through the usually R formula. They will give you the formula lah. So you don't have to go and memorize per se. So they'll say express this guy in this form. So they'll say express fx in this form. So let's say this question here, we want to express in this form. You can Google search this question. This is in the question bank. So you can just Google search this. They'll say express in this formula. So this already has R cosine x plus alpha. Okay, that's that. Then what you need to do is essentially just use if you've forgotten the formula, it's not an issue. You just cosine x cosine alpha. Then this is minus sine x, just addition formula lah. Okay, then you can just R cosine alpha bracket. So when I expand this guy, look at this the variable I just keep it as it is. So this one variable I keep it. So this will be negative R sine alpha, then sine x. Okay, so what we do is then we compare the coefficient. So usually what I'll say is, bro, you just compare this guy with this one. Check. I missed out something. Cosine. Yeah. Okay. Then you compare this one with this one. Okay, this one with this one. So what we do is R cosine alpha equals to 3. Then R sine alpha equals to 2. Then what you do is because you take 1 square plus 2 square, right? Like that, you sum it up. 1 square plus 2 will give R square cosine square alpha plus sine square alpha. Then this will be 3 square plus 2 square. Okay, so R just square root 3 square plus 2 square. Okay, that's it. Then if you use 2 divided by 1, you will get sine alpha over cosine alpha, R. It will just give you 2 over 3. So essentially this will be tangent alpha is 2 over 3. So alpha is equal to tangent inverse 2 over 3. Okay, so this is R formula. Remember, they will have to give you the R formula, then you just need to expand. So this guy here is how you show your R formula. Then from R formula, you know what is the maximum and what's the minimum. But I will suggest you Google search this question here in the question bank, 2027 specimen paper 2 question 11. Write it down. Try this question. Okay, it's in the specimen paper for a reason because it haven't come up. Then I will say that usually the student's nemesis obviously is not trigo function. A trigo is usually the pain point, okay, for obvious reason, because I think firstly the foundation have to be rock solid before you can even start a question, right? So just be mindful of that. Okay, so for trigo there's R formula. Remember that. We could go back and revise. I'll give you a worksheet on R formula, but please, if after the lesson I will immediately go and look for it, and I'll just put in the Telegram group chat, Okay, principal value. So okay, I will just explain quickly lah. So then, okay, firstly, understand this one. When you draw your sine curve, right, it's all in quadrant one, every quadrant. So like so you quadrant means quadrant just means a quarter, like 4 lah. So 2 pi, and then this is pi. This is what do you call it? Pi over 2. So this guy here, let me just draw it up. I draw this up. This is minus pi. Then this is minus pi over 2. Alright. So this is a sine curve. So what do you do with a sine curve? Basically, if you think about it, why do we have this as our principal value? We have this as a principal value so that when we solve our sine curve, this is a 1, 1 function. Okay, so this principal value, when I scope the curve down for the respective trigo curve, right, it will carve out a 1, 1 function so that when you find the inverse function, there's value. Because remember, this inverse function has to be 1, 1. 1, 1. Okay, so like in secondary school, when you do cosine inverse, tangent inverse, sine inverse, all the values you get from calculator, they are principal value. Because from the, okay, so if I draw the cosine x, right, so this is a cosine x graph 2 pi, and this is like 1. Let's say this is peak at 1. Peak at 1, so this is 1. Then this guy is -1 here, -1. Okay, so if you scope from 0 to pi, you realize 0 to pi is this guy here. It's actually a 1, 1 function. You cut the trigo curve out so that it becomes 1, 1. Okay, so tangent curve is the same. Tangent curve, obviously, because when you draw the tangent curve is a S curve, so there's a vertical asymptote here. So this will be like that. So this is x equals to pi over 2. This is x equals to minus pi over 2. So trigo function. So this is obviously the 1, 1. Okay, you can draw it like that. But you basically the domain you restrict it so that they are 1, 1. Now remember, principal means school principal, 校长. Okay, so basically it's a SI unit of angle. Like everyone just say, okay, this is the range that we agree. Obviously we want it closer to 0 as possible lah. Why would you want to make life complicated? So most of it, if you can include 0, we just include 0. We just take, because trigo curves are periodic, so we just want that part which is 1, 1. Okay, if not, the sine inverse, cosine inverse, and tangent inverse, they will not exist, this is under functions, right? Why is making 1, 1 important? Because in order for f inverse to exist, 1, 1, it has to be a 1, 1 function first, right? So under function, you know that you learn a lot of relationship in secondary school, right? Yeah, but not all relationships are functional. Such is life. Okay, so what you need to understand is basically when you go over, is a function because 1 input 1 output. Coming back is a function only for 1, 1 function. So basically, if say I've got 1 to many here, so if I got many to 1, sorry, 1 to many is not a function, so many to 1 like that. Okay, like that. So this one going over is a function, 1 to many, but when it comes back that time, when you flip this, right, this is no longer a function because you cannot have 1 input having 2 outputs. So that's why 1, 1 function is important. So that's why the principal values ensure that the trigo curve all has 1, 1. That's it. Any other question before I move on, bro? You have to have a scribble MM27. I'll give you mine, but you have to have one scribbled one because you have to know what is not given and what is given. Okay. Then after that, you review this video and whichever you don't understand, you just fast forward to whatever part you don't understand. Then ask. Remember this, for derivative, right? You can show this guy. This guy can be shown one. Okay, you can ask you to show that the derivative of this guy is this guy. Then obviously showing cosine secant to this guy is not very hard. You just to show the derivative of cosecant x, right? To this, you just need to write ddx. This is 1 over sine x. Then you just use quotient rule, or you can just use power rule, right? So like that, sine x minus 1. So it's minus sine x minus 2. This one will be cosine x. Then this will be 1 over sine x. Then this is cosine x. Cosine x is square, so you get this as negative cosecant x cot x. So this one is not very hard to show. Okay, so also remember that because you differentiate cosecant x gives you this guy, right? So you have to understand and differentiate secant square is this guy, right? You have to understand that you integrate. So note, this one maybe you want to put the note here. Note is that integrating negative cosecant x cot x, right, dx will be cosecant x then of course secant x tangent x dx will also be secant x. Just remember that. Okay, so if you see weird trivial integral, you please refer to MF27. Just know that you will also have these two free integrals here, but it's not very common to ask this question. Okay, just understand that. Okay, if they ever ask you to show this, just understand that you just let y equals to sine inverse x lah. Bro, if you cannot solve any derivative question, right, just understand that implicit differentiation is the answer. Okay, it's freaking differentiation on steroids. So you freaking just use the differentiation on steroids to solve. So you just move the sine over to the other side, sine both sides to get this guy, then differentiate with respect to x. What you want to find is dy dx, man. This guy will just be cosine y dy dx equals to 1. Once you're done already, you have dy dx equals to 1 over cosine y. Okay, and remember, if you want to get cosine y, what you need to do is understand that draw this, because now you need to change the algebraic form. So from trigo form to algebraic form, trigo to algebra, the connecting bridge is always the right angle triangle. Okay, my logo. Thank you very much. So this guy, you draw the right angle triangle because y is the angle, then this is x, this is over 1. So 1 square minus x square root. Okay, so this guy, you know that cosine y is equals to square root 1 minus x squared over 1 from the trigo here. Okay, then hence you get this dy dx as dy dx equals to 1 over square root 1 minus x squared. So wait, so this is d dx because your y is sine inverse. Okay, is that yeah, shown. Okay, so you do for the sine, you use the same method to show this. So this one, all the 5 expression here you can show one. It's not out of your scope. Okay, just use derivative differentiation. So the bottom two is easier. Just use this guy here, this quotient rule. Okay, any question before I move on to the integrals? So for the integrals, right, understand this, because so integrating this guy will give us this guy. Integrating this guy will be given this guy. Okay, this guy integrating will be this guy. This guy integrating will be this guy. Okay, how do we show these two? Actually, this one is very simple lah. This one, to show this, right, you can actually show this by how? Using partial fraction. So this is x minus a, x plus a dx. Okay, then you just need to show a x minus a plus b x minus a like that dx. You solve for a and b, right? Okay, partial fraction. You will get this guy. Okay, so you can show. I think you get half, if I'm not mistaken, or half a. Wait, let me see. A is by cover up rule. So a is by cover up rule. I know it's 1 over 2a. B is actually 1 over 2a also. Plus. Okay, like that. So this guy actually is by partial fraction one. So you will be simplified to this guy here. X plus a dx. Okay, so this will be half 2a ln x plus a. Then this is ln x plus 2 plus a here. Plus c, this is half a ln x minus a x plus a. Okay, understand? Let's see. Just understand that if you want to show from here to here, is by partial fraction. Then you integrate. Same thing, partial fraction, then integrate. So I don't think it's hard to see why it's like that. Okay, just partial fraction. The third one can show. So how do we show the first two? These last two you don't have to know how to show lah. If you really want to know, it's a bit you don't really need to know. It is not really like directly in your syllabus. I can show you the working later, but you don't have to like sweat. So the last two show is not really in syllabus per se lah, not directly. Okay, if they ever show also, you probably need some manipulation. So for the last two, you differentiate top and bottom by cosecant x and cot x. The reason being is because you can manipulate. So this one is not really in your syllabus, so you don't have to sweat about it. Okay, don't sweat about it. But this one, if you do the 100 integrals on YouTube, right, you will do something similar like that. Yeah. So, but not to the extent where it's so difficult. But this guy here, you see this ddx, right? This is cancelling method, the U substitution. Okay, this guy, if you ever see this kind of working in online, right, they are U substitution. Like I say, I don't usually do f prime x fx. Now I understand f prime fx. I totally understand the method of f prime fx. I understand. Okay, but if given any choice, right, I will always use U substitution because everything online is always U substitution. One, even for ChatGPT is U substitution. So yeah, so yeah. The easiest way is for this guy here to show, right, you reverse differentiation because from the first part, you already know tangent inverse. So you already know, you know that from the derivative, right? From the derivative. But this is not the only way. You can also use substitution to show this, but I don't want to show it because it's really not you need to use some substitution, some manipulation, but I'm not going to show it. Okay. But I think the easiest is to understand that because from the derivatives, you know that the what do you call it? Differentiating a tangent square gives you 1 plus x square. So essentially, you know that integrating 1 plus x square dx will be equals to tangent inverse x plus c lah. Okay. So if you let x equals to x over a, is it x over a? X over a, yeah, x over a. Okay, x over a. So let x replace x with let u equals to x over a. Okay, so essentially you have 1 over 1 plus x over a square here. So you have u, right, which is 1 over a lah. Differentiating that will be 1 over a. This is tangent inverse x over a lah. Plus c. Cancelling method. So then from here, you multiply the 1 over a over the other side. So this is u. Let u be x over a. Let x be u over a. Sorry. dx du. Yeah. So this guy will be u over a. So this guy will be basically you get 1 over 1 plus u over a square. Du equals to 1 over a tangent inverse u over a lah plus c. Okay. I mean, you can also see as basically you just take the derivative and show lah. Then you can see very clearly that yeah, this guy is this guy. How about the a in front? I got the a. Am I doing correctly? My mistake. So this one would be dx equals to 1 over a du. So this is actually correct already. This 1 over a. Yeah, okay, actually you manipulate this guy, you'll be able to show lah. Okay, so you can show that this guy is that the other guy lah. So but actually from the derivative there, you can show. Okay, so let x be u over a. Then you know that dx du is 1 over a. So dx is given by this guy. This is 1 over a du. Okay. Now I know a lot of schools say cannot write like that, but bro, Cambridge University textbook also write like that. The Oxford calculus textbook also write like that. So you are being marked by Cambridge lah. So you don't need to sweat. Okay. So but if your teacher don't allow you, but anyway your teacher is not marking your A-level paper, so it is nothing really. So you just rest assured that if it's in a university textbook, obviously yeah. So I just said. So this is it. You cancel this out. A square manipulate is like that. A square on top. So this is u over a. Then you get I just divide by a. I just divide lah. Then you get this guy lah. Okay. It's just a manipulation lah. So you can also start with actually all these like so tough, right? You might as well just start with tangent inverse x over a, differentiating this. So differentiate this is much easier. Okay. So you start with this guy first because you can do that. So from the derivative you can show these two lah. not an issue. But this is not the only way. This one is a reverse process of the differentiation. So actually I should have start with this. So this is easier. So a, then 1 over 1 plus, this is much easier. Then you know that integrating this guy will give you the other guy. Okay, so this is not the only way to do it. I repeat, there's a one substitution way to solve, to show, but I'm not going to do that because that one is a bit out of syllabus really. Okay, so that's that. So remember, you differentiate by differentiating these two, right? This one and this one, you can get the integration. They are the same now. Okay, so about this one, tangent and chord, how do you show this guy? Okay, this one is cancelling method lah. You can actually show by using cancelling method or f prime fx. Cancelling method, if you don't know what is cancelling method, just use MF, just search for 100 integrals H2 math, then you see the video. I'll teach you how to do cancelling method. But if not, you can just use the school f prime fx method, not an issue. So this one, if you want to solve this, you just break it down to cosine x, like that, dx. Okay, then you get this guy to be your u equals to cosine x. So du dx will be what? So this guy will be sine x, because you make this u du, differentiate cosine will be negative sine. So cancel this out. Will be actually negative 1 over u du lah. So this is just negative ln u, negative ln cosine x. Okay, but see, then you say, how come I don't get the secant? Because this negative one bring up will be this guy. You bring it up lah, like that. Ln power rule of a logarithm, so you get that as ln secant x plus c. Okay, so that's that. So shown. So if you want to do the f prime fx method, is the same. This one will be sine x, then cosine x dx. This will just be negative sine x cosine x dx. So you must be able to recognize that this is negative ln cosine x. Okay, then it's the same thing. You do the same thing, then it'll be ln secant. Okay, so that's it. Yeah. Okay, so this one is just by cancelling method or the f prime fx thing lah. Okay, so the formula, I just use cancelling, easier. Cancelling. Okay, is that mod x to the power minus 1 is the same as mod x if you apply the negative 1 inside, because you apply to the same thing. So you for mod you can do that lah, it's the same. So but if not, you okay, actually you can bring it up lah. You can, yeah, you can apply to the entire thing, then the reciprocal of this entire thing is 1 over mod x ma. So it's still the same as this guy. Both are the same. Yeah.
But the gist is that it applies to the whole thing.
Yeah, the whole thing. It has to be the whole thing. Yeah. So the question is then whether we need to mod this guy. Okay. Don't need to, because we this one, what does this mean? This one means is in the this one ensure that it's modulus really lah. This one also ensure it's modulus. You can put a mod, don't put a mod, it's fine. Yeah. Doesn't matter. But basically x is between minus pi over 2 and pi over 2. This means what? This means this is in quadrant 3, okay, quadrant 4 and quadrant 1. Okay, cos minus this is my pi over 2, is minus pi over 2, right? Okay, so this is quadrant 1, quadrant 4. Quadrant 1, quadrant 4 has this cosine x is what? Cosine x is positive for both quadrant 1 and quadrant 4. So this one would already ensure that this entire thing is mod. So but when you're using the MF27, you just put a mod, it's fine. Yeah, you don't have to worry about it. In exam, right, just mod your ln. Don't sweat. I know some school, like some teachers will say, oh, you need to know that it's always positive. Don't sweat really, bro. They are the same thing. You mod it, you don't have time, you just mod it. You don't know whether it's always positive or not. You mod it, they cannot fault you for being wrong. It's confirm correct one, yeah. So they can say whatever they want, but in it, come on, bro, let's be sensible, yeah. Just on. So for Maclaurin series, the validity are here. So just make sure if you replace x with x over 2, then the validity will just be x over 2 less than 1, which is whatever you replace is this. Same with this guy. Okay, if you look at this guy here, is at mod x less than a lah. So for example, right, if say I've got square root a square minus x square dx, right? Let's say this is 3. Okay, so meaning my a is what? My a square is equals to 3. So a is equals to square root of 3 lah. So it will only be valid when I use mod x less than root 3. So essentially, what I'm saying is if you sketch this curve, it will only exist between this value here. So I'll show you. The graph, you don't need to worry lah. For this y equals to root x graph, right? Definitely the validity would be between this guy, because how do I know that these are the vertical asymptotes? This one. So how I know this is a vertical asymptote is because if I were to you cannot be 0, just let x be 0, but yeah, so the asymptotes are when the denominator are 0 lah. Okay, so you don't have to worry so much about the validity here lah. You don't have to worry so much. Just take note that if, say, usually this is what's going on. If, say, you have x squared is positive, let's say this is okay, the one thing that sometimes I see students make a mistake is this one. Okay, like this one and this one. We have roots. Let's say this is minus 1. Okay, just take note of this one. If this is negative, okay, if this is negative, don't sweat just use the negative one. Then if this is positive, you use the positive one, the coefficient one. That's all you need to know. Okay, so for long-term supporter of TGM, you know that I say the entire thing about the MF27. The most scammy part is the freaking vectors. Vectors, you know, conventionally you likely will have 2 questions in A-level paper, right? And of the entire MF27, right, these are the only 2 pathetic result you get for vector solution. Vector cross product and ratio theorem. Okay, so ratio theorem. So essentially, if you don't practice the vectors, you go into, if you really think that your MF27 is going to save you from vectors, right, you are in it for a treat lah. Okay, this is like basically double thumbs up for you lah. Okay, so I'm gonna explain to you how ratio theorem is being derived. Okay, how ratio theorem is being derived. Okay, so ratio theorem is being derived is very simple one lah. Say if you have this guy here, this is A and B. So we have, let's say, A, then P is being this is B, right? So this is mu and this is lambda, not an issue. Okay, so ratio theorem is always the middle guy that you want to find, the middle guy that you want to find. Okay, so I think this is just secondary school integration. So okay, you remember what I say about vectors, right? That you only need 3 things to cross product, dot product, and magic triangle. The reason why I don't consider ratio theorem as some students will say that you need the 4th thing, which is a ratio theorem, right? But the reason why I don't consider it as something you need to know is because you can actually derive it one. Okay, but okay lah, fair. 3.5 thing, maybe you need a ratio theorem. So this guy here, this is how you do. Because you know that AP, right, is a ratio of AB lah. How do you write this one? You write this as mu over lambda, mu plus lambda, right? You agree? This one no choice lah. Just the entire thing is mu plus lambda. Then you have AP, which is the length of mu. So this is ratio is like that, right? So how do I then do it? So it's very simple. I put this as OP minus OA, which is A to P lah. No an issue. This is mu over mu plus lambda. No an issue. This is OB minus OA. Okay, is it? So then I just need to multiply to the other side. So this one, if I multiply to both of this term here, cross multiplication to these 2, I will get mu plus lambda OP minus mu plus lambda OA lah. Then this one will leave with my OB minus mu OA. Okay, remember my goal here is to make OP the subject. Ratio theorem. So this guy will be mu plus lambda OP equals to mu OB minus mu OB OA plus mu plus lambda OA. Okay, so this guy will be mu OB plus, if you factorize everything out, then this is OP. Here you go. You show the ratio already. Mu OA OB. So that's that. Okay, so you have yeah lah, my lambda and my mu is different from, so lambda times OA, yeah lah, the same. Okay. Remember my sorry, I used the opposite rule. So if you want to get the answer here, you just do what they say. I didn't label it as what they mentioned. So I swapped the mu and lambda lah. I didn't follow the lambda and mu. Okay, that's that. This is obviously not MF, then it's H2 math, so don't worry. This is also not in H2 math, don't worry. Okay. All these are not in H2 math lah. Then just remember that the only thing that you probably need to worry is the binomial expansion here. So the binomial distribution, sorry. So there's a mean, there's a PDF and variance. Then you have your sampling. This one I don't need to explain. And the linear regression. Sampling, probably the only thing you need to know, which is not in MF27 yet again. So is that this formula from hell, I asked you to memorize this, right? So this is n minus 1 sigma x squared. So this one, sampling, this is a sample standard deviation. So I say that I usually don't ask students to memorize formula, but when I ask you to memorize, you know that shit hits a fan. So this one have to memorize. This guy, this is your sample standard deviation. So know the difference between S, sigma x, and sigma. This is population standard deviation. Okay, this one is sample. Actually, this S is also population, but it's unbiased estimate lah. So these two are unbiased estimate of population standard deviation. They belong to the population. Okay, so this one you can refer to the H2 math summary notes that is written there. So just do. Now then the next part is to understand what formula is given at MF27 and what formula are not given at MF27. So that one I think I will consolidate everything for here. So at a glance, remember our formula is not given at MF27. Okay. Our formula is not given. Shoelace method, remember, shoelace method is not given also. Okay, so I mean, for what we have already gone through, the formula not given at MF27, I already talked about the R formula and also the sine square A, cosine square A. And then we derive how to show. So you just go back. I'll give you the R formula worksheet later with all the questions which will come up. Okay, prelim. Then just remember also arc length is not given. So we mentioned about arc length the last lesson. Arc length is S equals to R theta. So it doesn't hurt for you to remember. Basically, arc length is let's say you want arc length. Okay, this is R, this is theta. You want this arc length here. So you know that S is let's say if it's in degree, theta squared over 360, right? Then you just multiply by circumference 2 pi r. Okay. So if you want in radians, obviously everything is in radians. So S is equals to R over 2 pi instead of 360 degrees. Okay. Then you multiply by 2 pi r. So this will be R theta. Oh, sorry, this will be in degrees theta, R theta. Okay, so arc length is R theta. You do the same for area of sector. Area of sector will be theta over 2 pi r squared. Okay. So know how to derive them. Because if you forget it now, you confirm or forget it during exam one. Always have a fallback mechanism so that you don't shit in pens, right? Or pee in pens. Depending on how severe it is. Area of sector A equals to half r squared theta. Okay. Also remember, cosine rule is not given in MF27. Cosine rule is basically A squared equals to B squared plus C squared minus 2BC sine A. Okay, so cosine rule, we use it quite extensively in Maclaurin series when it comes to small angle approximation and stuff. So remember, this is A, B, and C. This is A, B, and C. Okay, so this is your A, angle A here. So this is how you use the cosine rule. Now, when do you use cosine rule? You use cosine rule when you have more general rule of thumb. I'm just saying rule of thumb, okay? don't say Mr. Gun say, or just remember Mr. Gun's thumb say one, just a freaking rule of thumb, because I do not know what you're gonna see, but generally you have more known lengths, then you use cosine. Basically, usually it's just one angle in the diagram, then you use cosine rule. So you have more length, you use cosine rule. Then the other one which most of you remember is a sine rule. Sine rule is just sine A over A, sine B over B, sine C over C lah. So basically you use it when you have more angles, more known angles, you use sine. Okay, so obviously a bunch of remember all the other vectors formulas. Okay, please don't go into exam thinking that the formulas are given to you. So you need to know your dot product, cross product, your magic triangle, then your line equation, your plane equation. So those are the things you may need to know. So for your magic triangle, remember your magic triangle is a Tokaso and steroids. That's all you can say. I also can say. Okay, so you to get the opposite is just A cross B unit vector, the adjacent vector. Then this one is A dot B unit vector, adjacent vector. Okay, that's it. Now, of course, you have your plane equation, line equation. That one is just line equation is RA plus lambda D. Okay, there's a line. Then your plane equation, we usually use the what do you call it, scalar product form. So this is not given. So we prefer this value here, this one. This plane, this is line. Okay, so I don't need to talk so much about this. This one, I think if you have problem, you probably cook by now, huh? So remember simple geometrical shapes, the formula. So like sometimes I see students forget about area of trapezium. Area of trapezium, let's say you have this one, area of trapezium. Okay, remember for the parallel sides, the area is you take the average divided by 2 times height. This one sometimes I feel that students will forget. Okay, then also area of parallelogram. Okay, it's very simply just base area, base length times height. So the area is just the base times height. That's all. Okay, so that's that. Then area of sector we covered already. Yeah, so I think this one generally it is. Then like for example, like volume of pyramid is 1/3 base area times height. Okay, so remember a cone, although it's not really a pyramid, but it also adhere to this shape lah. So like tetrahedron, like basically you need base area times height. So cone is the base area is pi r square. Okay, but tetrahedron and like all the pyramid usually they will write in the exam script lah. Okay, so the one that I think you may want to pay attention is the trapezium lah. So if you've forgotten, just the average the average of the two of the parallel side, then just multiply height. That's it. Okay. Then let me see. What else? Then there's a shoelace method. Remember, shoelace method is you say in a rectilinear figure, right? It's A, B, and C. Okay. You go to your, it's the secondary school notes also got the shoelace method. You can go and refer to the area of rectilinear figure. Usually this is what we encourage you to do, is that you write in anti-clockwise manner. Usually it's in anti-clockwise manner. Okay. You start with like, this is X A Y A, then this is X B Y B, this is X C Y C, and this is like X D Y D. Okay, so you start with either one. So you can start with A, B, or C. So you can start with C first, then X D. It's better to be anti-clockwise. So then A, xb, yb, then you end with xc, yc, okay? Then you just multiply this across, sum them up, then you minus off this guy, sum them up, okay? Remember shoelace method. Just remember shoelace method. Always take anti-clockwise, then just multiply below, and just shoelace. Okay, another type of question they like to ask is this one. They give you a line equation. Give another line equation. They ask you the angle between them. Okay, so say this is y equals to 2x. Say this is 2x minus 1 plus 1. And this one is like say this is y equals to negative 2 over 3x plus 3. Okay, they ask you to find the angle between them. Now remember this, you have to remember this. This one is important. This in secondary school, I'm not sure if it is like not emphasized well enough in secondary school, but whenever you have an angle like that, this is m equals to a value. Okay, the angle, the m is equals to tangent theta. This is important. M is equals to tangent theta. So what you need to understand is, if say m is equals to 3, okay, or let's say m equals to 2, then the angle between them, tangent theta, is equals to 2, is tangent equals to 2. Okay, so this guy here, if you use a GC, so obviously your GC is in radians lah, remember that. Okay, please don't change your GC to degree. Please don't do it, okay? I've seen enough tragedy to, okay, I know some teachers will say change to degree, then change back to radian. But right, I've seen enough tragedy to conclude that it's a bad idea. Okay, you change to degree, the problem is you forget to change back to radian, you get framed. Okay, and most of the time it's okay to write your angle in radian, but it's not okay at all for the entire question to have your calculator in degree, because for parametric equation it won't work. For a lot of other trigo stuff, it will not work one. So please don't change it to degree. Okay, this is important. So this guy, tangent theta, tangent inverse, right, would just be 1.107. This sorry, tangent inverse 2 will just be 1.107 radian. Okay, so if you want to change to degree, you just multiply 180 divided by pi. It'll be 64. Usually this is what I'll do, but if not, you just use your Casio to change it. Okay, but don't change your mode to, so this is 63.4. okay, so if say I've got radian of negative 2/3, y goes to m equals to negative 2/3. Okay, now remember this one. So if I were, okay, then if it's negative, what do you do? Okay, so maybe tangent 1, tangent 2. I just put this as angle 1, angle 2. So tangent theta 2 is equals to negative 2/3. Now remember, we just now we learned something called the principal argument. So principal argument, this will be negative 0.588. So this theta 2, if you tangent inverse that time, you get negative 0.588 radian, which is 3SF. So this guy, I'm gonna take this, multiply by 180 divided by pi, so that I'll get my, this minus 33.7. So essentially what happens is this is negative 33.7 degrees. Okay, negative angle means you just swap from, it's always from the positive x-axis, swap it down. So this is it. Okay, now once you get that, okay, maybe I should use more than 1 dp so that I won't get into trouble later. This one also change to one more than 3.43. Okay, so this one be positive is this guy. You all know why degree we always put in 1 dp, whereas radian we can put in 3SF. Okay, So I mean I explained this why before lah, but the reason why is because the instrument that we use to measure degree is only accurate to 1 dp, which is the mathematics projector lah, mathematics projector. So this one, okay, this guy here, because we can only measure this to a degree of 1 degree, so that's why we usually leave it in 1 degree. Okay, but radians is different. Radians is actually a formula. So if I want to find the angle this guy between these two lines, right, you have to just use your geometry law. So this guy here is 63.43 degrees. This guy here by just 33.69 degrees. So this guy is obviously vertically opposite with 33.69. So to get theta, the angle between them, the angle between these two lines will be 63.43 plus, oh sorry, you can take minus lah, but you can just take this guy minus of this guy to get this guy. Okay, but whichever, you can take 180 minus this, but essentially you just take this one minus 33.69 degrees. Okay, angle between them will be 29.7 degrees, 1 dp. Okay, angle between lines. Okay, question. If you've forgotten about this, what you do in exam, you can just use you can just write it in vector form. Okay, so how do you write in vector form? If you want to find this angle between them, right, it's very simple. Because you know this is 2, right, you can use dot product. You just use product. 2 meaning to say the rise is 2, the run is 1, right? So the y-axis, so you can just, the y is 2, the x-axis is 1. So the direction vector here is 1, 2, 0. Understand? You write this as 1, 2, 0. Then for this guy here, if you're going down in this direction here, so you have this side here, rise over run. So the rise over run, rise is 2, this is run. So the run you can let it be minus 2 lah. So essentially you're going down by minus 2. Okay, then this one going, so this one you can let it be 3 minus 2, 0 lah. Then you just take the 2 dot product to find the angle between the two lines also can. Okay, so but still remember m is equals to tangent theta. M equals to tangent theta equals to dy dx. Okay, so these are essentially the comprehensive formulas that you need to know for your, I don't know what, I think these are the major ones, so I'm not sure what other things we I think these are the things I could think of, and I've written down in my past scribble MF27. Because my diagram is wrong, sorry, my diagram is wrong. So my diagram, this one should be the obtuse angle. In my diagram, my this diagram is not accurate. So essentially the diagram that I get, right? No, my diagram is not accurate. Your question is not wrong, but my diagram is not accurate. Yeah, it's not accurate drawing. This angle here is supposed to be, this angle here is an obtuse angle. Yeah, it's not obtuse. So actually I should draw the accurate drawing, then I can see lah. So this one minus, yeah, this one is obtuse. So I should get, yeah, my acute is this side actually. So you're right to say that, but my diagram is, so my diagram is wrong. Sorry, this angle should be, this angle that I get here is not this one. It should be this one. My bad. 97.1. Yeah, so sorry, this is 97. This one should be acute. So yeah, so then basically the obtuse, so the angle between them will be what? 180, 82.87. So the acute angle between line is 180 minus theta, which is like 82.87, which is 82.9 1 dp. So my fault, this one should be 82.9 over here. Yeah, So yeah, so I take this sum of this and this sum together will be sum of exterior angle, but this guy is obtuse, so the angle between them is 82.9. Yeah, not, I did the wrong one. Okay, any other question? So if you've forgotten your m1 is equals to tangent theta, right, what you need to do, you just basically just write down it in column vector form, then you find the dot product.